Hi everyone, Mr. Ang here. So in this video, we're going to go through the 2023 end of year paper for the 3E combined physics exam. So we first start off with paper 1, that is the MCQ questions. So for question 1, what we have is a question on units. So the question asks which of the following is equivalent to the joule. So this might be a bit of a confusing question, but really it's asking you to identify what are the SI units of the joule based on the base units. The joule, along with some of the other units that you might be familiar with, such as the Pascal or the Newton, okay, while they are SI units, they're not the base SI units. They are derived SI units formed by a combination of multiple SI units. So one example would be area, okay, a simpler example, because the base SI unit would be length in meters. Area is not a base SI unit, but the units of area would be meter square under the SI system. So looking at this, what would the equivalent of the joule be that would require us to understand what the joule means as a unit? And an easy way of thinking about it is looking at a formula for something that gives us joules and the other side has other units. So what we do have over here is, okay, the formula for energy in a kinetic store, or you might otherwise know it as kinetic energy. So EK equals to half mv squared, and the units on the left is joule, the units on the right, they must be the same unit. So half doesn't have a unit, so you notice in the second line I've omitted it. But for mass, that's kilograms, and for velocity, the SI unit is meter per second. Of course, because it's squared, we have to do that, and this is the units. And if you see in the question, we do not have a divide sign, so you have to get comfortable with this. This might come out eventually, okay, that the index being negative shows that it is divided by. So s to the power of negative 2 means you are dividing by s to the power of 2. So our answer here would be D, kilograms meter squared, seconds to the power of negative 2. So for question 2, which of the following is correctly categorized? We've got scalars and vectors. So what you need to remember are the definitions of scalars and vectors. So scalars are quantities with a value or magnitude with no direction, whereas vectors, they do have a direction. So from these pairs, okay, you can see based on your understanding, okay, the answer should be C because mass has no direction while force has a direction. For the other three options, at least one of them is mischaracterized. So you can pause the video here and then slowly figure it out, or if you're done with that, you can move on to our next question. So question 3, which of the following instruments will be most useful in determining the density of a ring? So we got a digital micrometer screw gauge, digital calipers, measuring tape, and a meter rule. So I think all of us are familiar with how a ring looks like. And the answer here would be the digital calipers, because if you look at the digital calipers, it will have internal jaws to measure the inner diameter of a ring. So that is the opening of the ring, as well as external jaws that can measure both the outer diameter, so how wide the ring is, as well as the thickness of the ring in many different types, okay, of across the ring, or the thickness of the ring, or the width of the ring, and so on and so forth. You can't do this with a micrometer screw gauge because the inner diameter is not something that a micrometer screw gauge can measure. Neither could you do so with a measuring tape or a meter rule. Question 4. A train travels south at a constant speed of 15 meters per second along a straight horizontal track. At time t equals to 5 seconds, its velocity starts to change and has an acceleration of negative 3 meters per second. So they want to know what the train's movement is at t equals to 9 seconds. So from 5 seconds to 9 seconds, that is 4 seconds. And if we plot a speed time graph, this is what we will find. I've not labeled the axis here just for convenience. You will realize that From 0 to 5 seconds here, it's traveling at a constant speed of 15 meters per second. Then over here, we've got 4 seconds of a constant acceleration. Notice the gradient is negative because the acceleration is negative. I've put a dotted line here because we are stopping at 9 seconds. We are trying to find out what the train's velocity is at 9 seconds. Okay, but if you do the math, you will find that at t equals to 10 seconds, it will actually come to rest at that moment. So at 9 seconds, you will see that it still has a positive velocity, which means that it is traveling south. So it's either C or D. But looking at the gradient of the graph, this is also very obvious. It is doing so at a decreasing speed. So the answer here is option C, traveling south with decreasing speed. However, if I were to ask you at t equals to, let's say, 11 seconds, then this graph would be extended beyond our axis. Okay, now then this velocity time graph would then be at negative velocity. That would mean that it is moving north instead, and it would actually have an increasing speed, because while the graph has a negative gradient, it is getting faster and faster, further and further away from stationary. So please be very careful about this. Question 5. A pebble is dropped in a vacuum chamber on Earth. The air in a vacuum chamber has been pumped out, and then the entire experimental setup is brought to the moon and repeated. And we're asking for the difference between the two experiments. So the first thing you have to notice is that the air was pumped out. And when you pump air out, this gives you a very big clue, because when something is falling, okay, the air is what provides some air resistance. So looking at our options here, you will notice that terminal velocity is mentioned. However, when you do not have air in free fall, you will not have terminal velocity, because terminal velocity is the maximum velocity of a falling object due to its weight being equal to the air resistance. Over here, there's no air resistance, so there is no maximum velocity. The pebble will continue accelerating as long as it has not hit the ground yet. So that is why options A and B are both wrong. The pebble is not going to reach terminal velocity on either the Earth or the Moon. For C and D, the time taken for the pebble to reach the ground, okay, we're just asking whether it will take more time to hit the ground on Earth or more time to do so on the Moon. Based on our understanding of the gravitational field strength, we know that the gravitational field strength on Earth is about 10 newtons per kilogram, and that means that objects accelerate at 10 meters per second squared when they are released. On the Moon, it is weaker. You do not need to know exactly what the value is, but for those of you who do remember it, okay, it's about 1.67 meters per second squared, 1/6 that of Earth. That means that it takes a longer time, or there is less acceleration. So it takes a longer time to accelerate to a certain speed, and that would mean that the pebble would take a longer time on the Moon to reach the ground if it were dropped from the same height. So our answer here is option D. For question 6, we've got 4 different objects placed on 4 different planets, and we are finding the gravitational field strength. We're looking for the highest one. So what we need here is to remember our formula for weight, or the formula for gravitational field strength. They're both the same formula, just rearranged, making either G or W the subject of the equation. So what we would have here is G equals to W over M, the weight divided by the mass. So like just now I said that gravitational field strength, its units are newtons per kilogram. So if you get confused, if you remember the units, then that tells you it's weight over kilogram rather than the other way around. That is a common mistake that students can sometimes make. If you remember the units, or you understand what gravitational field strength is, then that is one way to avoid making that mistake. So very straightforward maths, divide the weight by the mass, and you will find the answer is A. Question 7. Okay, so this object has a mass of 600 grams and certain dimensions with a hole through the middle. The question asks for the density of the object. So what we need is the formula for density, and that is rho equals to m over v, mass divided by volume. Doing the quick calculations of the volume, which I will not go through here, you should get that volume equals to 144 centimeters cubed. So dividing 600 grams by 144 cm cubed would get you B, 4.17 grams per cm cubed. Question 8. We have a plastic ring hanging from the top of a tube, the tube moving to the right at a constant speed where it was stopped suddenly. Then we want to know what the plastic ring looks like while the tube is decelerating as it comes to a stop. So this actually is testing the concept of Newton's first law. So what Newton's first law states is every object will continue in a state of rest of uniform motion, okay, in a straight line, as long as there is no resultant force acting on it. So in that moment where the tube is starting to decelerate, the plastic ring hasn't experienced any changes in its force. There's no net force, no resultant force. Therefore, it would want to continue moving towards the right at the same constant velocity. However, because the tube has stopped, that means that the tube is not moving, but the ring continues to move, and you will get B as the configuration of the tube and the ring. So question 9, plane is flying at a constant height and a constant speed to the west. We want to conclude about the magnitude of the forces. Looking at this is again Newton's first law because it's traveling at a constant velocity. Its height is not changing, its speed is not changing, it is not changing direction, so there is no acceleration and therefore no resultant force. Because there's no resultant force, that tells us that all the forces here are balanced, meaning that lift equals to weight, engine force equals to air resistance. Looking at the option, just be very careful not to confuse C and D, and the answer is D. Lift and weight are equal to each other, acting in opposite directions, which is why the resultant force is 0. 10. We have a wheel moving towards the left and we want the direction of friction acting on the wheel. So very important to remember that friction acts to oppose motion. So if the wheel is moving towards the left, friction would be acting towards the right, and you would get C as your answer. And if you think about it, okay, and analyze this using a different chapter, the turning effect of forces, you will also realize that if a wheel is moving towards the left, okay, it will want to be rolling in this case an anti-clockwise motion. So what type of force gives an anti-clockwise moment about the pivot here in the center? Again, it would be C, causing that anti-clockwise motion. Okay, so if I've got a wheel that's skidding, it wants to start rotating, friction is actually what causes, okay, wheels to rotate. 11. A non-uniform laminar freely suspended around P has a center of gravity at C. It's displaced in this position, and we want to find the perpendicular distance from the line of action of the weight to the pivot. So the first thing we want to understand, or the first thing that we need to apply, is the understanding or the concept that weight acts from the center of gravity. So looking at the question, the center of gravity is at C, and this point here being the center of gravity means that weight acts upon it. Notice as well, even though I've got weight acting vertically downwards, I've also drawn a dotted line because the line of action extends beyond the weight. Okay, I do not have the space here, but the line of action could also extend past downwards, but that's not necessary in this question. Next, I want the perpendicular distance, and it tells us line of action to the pivot. So my pivot is here at P, the line of action is here, so the perpendicular distance must therefore be this distance here, perpendicular, okay, to the line of action. Looking at this distance, it clearly matches up D2, so option B is the answer. Question 12. A non-uniform object is placed on a slope that's about to topple. So which of the following is the most likely center of gravity of the toy? So again, using the concept from the previous question that the weight originates or seems to come from the center of gravity, let's try and draw the weight for these four different center of gravity in the question. So you see over here, I've got four arrows. Notice, okay, that only for D is the weight passing through this point here. And if we think about the definition of toppling, toppling means that it would rotate about this pivot here. It would rotate in a clockwise manner about this pivot. For points A, B, and C, we see that these points all provide a counterclockwise or anti-clockwise moment about this pivot here. With my laser pointer, I'm pointing at, and D has no moment because the force or the line of action of the force passes through this pivot, and therefore there's no perpendicular distance and no moment, no turning effect. Because it's just about to topple, this is the most likely center of gravity. If the center of gravity was any further past this point, then it will be creating a clockwise moment, which would then cause the toy to topple over. Because in this diagram here, there is only one force acting downwards. The upwards forces, the normal reaction forces, they are not being shown, but they definitely could not be providing any form of a anti-clockwise moment, because any normal reaction force would be in this type of direction. They will all be a clockwise moment. Question 13. This is something you just have to memorize, the primary energy store for hot water. So keyword here is hot. So as a quick reminder, these are our 6 different energy stores that we learnt about. We've got 3 potential stores: chemical, elastic, and gravitational potential, as well as 3 other stores: kinetic, internal, and the nuclear store. So for hot water, we are looking at option A, the internal store. So for 14, we have an athlete lifting a dumbbell, 10 kilograms of this dumbbell at a constant speed. He uses 4 seconds to raise the dumbbell to a height of 50 centimeters. What was the power he exerts? So we need to understand firstly what is the definition of power. So power is work done over time or energy transfer over time. Work done and energy transfer, as we've mentioned before and we learned before, these are the same things. And over here, the work done would be the work done against gravity or the energy transfer into the gravitational potential store, which is why I've put here mgh divided by T. Once we substitute in the values, you will find the answer is B. However, please be very, very careful. I think a common mistake that students would have made if they were rushing or they were not careful, okay, a careless mistake is putting 50 into the height instead of 0.5. You have to remember SI units are very important. So you need to convert everything to SI units. Another mistake that students might make is forgetting that 10 kg is just mass. This does not give the force. Some of you might have used a different formula for work done, that being force times the displacement or the distance traveled in the direction of the force. But 10 kg is not the force. The force is weight. So you have to actually multiply by 10 newtons per kilogram to get 100 newtons. So both of these methods actually would give you the same answer, as they should, because they're really the same concept. The work done by the athlete lifting, working against gravity, he is transferring the energy into the gravitational potential store, which is why F times S is the same as mgh. So for question 15, okay, this is actually outside of the syllabus, but the answer here is actually C. So C actually describes the process of evaporation. We are not going to learn about evaporation in our syllabus. So for thermal processes, we are actually only going to talk about the 3 main processes of conduction, convection, and radiation. Now, for boiling, okay, we are looking at what the different energies are, or in the case of option D, how the particles behave. So for boiling, we know that there is a change in state. And we also learned that during a change in state, the temperature remains constant. That is why we can define a boiling point or a melting point for the changes of state from liquid to gas or solid to liquid, respectively. Now, since the temperature remains constant, and we know that temperature is a measure of the average internal kinetic energy of the particles, that means that during the process of boiling, the internal kinetic energy of the substance is constant. But boiling means that there is some form of energy transfer. You are heating this particle or this substance. So you're transferring energy into the substance. And what this is actually doing is to increase the internal potential energy because you are doing work against the intermolecular forces of attraction. So between the water particles or between the liquid particles, sorry, because we're not talking about water specifically, the particles actually have strong intermolecular forces that require energy to overcome. And this would increase the internal potential energy, similar in analogy to, for example, stretching a spring. So, in all, what you will get is the total internal energy would increase because while the internal KE remains constant, the PE increases, and internal energy is the sum of potential and kinetic energies. So looking at our options, okay, the answer would be C. Internal potential energy increases. Question 17 actually is a very simple question. It's asking which of the four rods have the best thermal conductivity. So you see over here that A has the most melted wax and D has the least. So looking at our options, we've got wood, iron, glass, and copper. We do know that metals are better conductors of heat. So the answer should be C. Copper and iron being the metals, glass and wood being the non-metals that are poorer conductors of heat. Now, why are metals better conductors of heat? That's because they are materials with free or mobile electrons, and these free or mobile electrons, they are able to conduct the heat through the vibrations and through the collisions much more quickly and effectively than materials without the mobile electrons such as glass and wood. So generally speaking, materials with these free electrons, meaning that they are conductors of electricity, will also be very good conductors of heat. Question 18, we have a candle that's lit and point P on the underside of the cover. We want to know the main methods that P receives heat from the candle flame. So the answer here would be convection and radiation. Main methods, okay, while conduction will eventually occur, it does not do so significantly because air is a poor conductor of heat. And why is air a poor conductor of heat? Because conduction requires the collisions of particles with their neighbors. And in air, as we learnt in the kinetic particle theory, gases have very low densities because the particles are very far apart, so the collisions are very infrequent, and therefore gases are poor conductors of heat. However, because gases can flow and they can expand and contract and change in density, convection currents are very easy to set up within gases and also within liquids. And thus, you will have a convection current occurring above where the warmer, less dense air would rise, and then the cooler, denser air would take its place. And then this cycle would repeat and cause a convection current. And of course, radiation would always occur as long as there's nothing in between directly absorbing the radiation, such as a piece of metal or some material. You would have radiation through the box. 19. So we have water waves traveling from a deep to a shallow region, and we have the speed, frequency, and the wavelengths. How would they all change? So you might notice something interesting. How come the speed here all are the same options. Does that make it redundant? Actually, that is not the case. And why is that not the case? Because we need this information from the virtue of the fact that the wave speed equation tells us that the speed of the wave is given by the product of the frequency and the wavelength. So V equals to F lambda. The other thing we need to remember is that during the change of a medium, what happens is that the frequency of a wave does not change as it travels from one medium to another medium. So from a deep region to a shallow region, the frequency does not change. And what happens is we've got no change. So in order for the speed to decrease, this product must decrease and therefore the wavelength must decrease. So our option C is the answer here. Then as for 20, we've got displacement time graph and a displacement distance graph of a wave. So over here you can see the displacement time graph and displacement distance graph. So we can find out the period, which is one cycle here, 8 seconds, as well as the wavelength, which is over here, lambda, 4 meters. So based on this and the wave frequency, that would be 1 over 8th of a hertz, okay, or 0.125 hertz, because the frequency is given by 1 over the period. And using the equation that we just looked at earlier, V equals to F lambda, 0.125 multiplied by 4 tells us that the speed of the wave is option A, 0.5 meters per second. So we've come to the end of our MCQs. So please go back to any of the questions that you might require a little bit more time to understand. Okay, and when you're done with this, in the next video, we'll start to look at the structured questions.